Maybe it didn't seem like it, but hoisting is actually a fairly straightforward process. So let's just go through the different scenarios here, starting with variables. So let's just create 3 variables here using the 3 different ways of declaring them. So now a let for the job, teacher, and then const for the birth year. Let's just call it year 1991. And now let's try to use all of these 3 variables before declaring them, just to see what happens. So me, job, and year. So from the rules that we learned in the previous lecture, what do you expect will happen now? Well, the first console.log results in undefined. And that's because variables declared with var are actually hoisted, but they are hoisted to the value of undefined. And so therefore, when we try to access them, undefined is exactly the result that we get. And so that's the reason why we see this here. Then on the contrary, we have this let variable. And so here we see that we cannot access job before initialization. And so that's exactly the kind of error that I showed you in the last slide. And the origin of this error is the fact that the job variable is still in the temporal dead zone here at this point, right? So remember that the temporal dead zone of a variable declared with let or const starts from the beginning of the current scope. And so that's basically here. So in this case, it's the global scope. So from the beginning of the scope until the point of the code where it is defined. And so here. And this means that at this point, of course, the job variable is still in the temporal dead zone. And the same is true for year. And so now we get the same error here for the year variable as well. All right. So let's comment out both of these. Let me just write here that this is hoisting with variables. And now let's try out functions. So let's create function declarations and function expressions here. So function, and again, I will use a simple add. And let me just call it add decl, which stands for declaration AB, and return A plus B. And now a function expression, so add expression and once more return A plus B. And now, since we're doing these two, let's also create an arrow. So add arrow AB and return A plus B implicitly. So I hope you remember that this is how the arrow function works. And now, once again, let's try to use these functions before they are defined. And so I will log them to the console. So the result of calling them, because they return something. And so we need to log the result to the console. So as you already know. So let's add 2 plus 3. And now what do you think will happen? Do you think that it will be undefined again, just like we have here with the var variable? Let's see. And no, we actually get the result of 5. And so indeed, we were able to call the function declaration before it was actually defined here in the code. All right. And now let's try the same for the other two. Expression and add arrow. But now I hope that you can already anticipate what is going to happen. And so indeed, we get an cannot access add expression before initialization. And so that's exactly the same error that we got before here with these let and const variables. And that's because this function here right now is simply a const variable too. And so it means that it's now also in the temporal dead zone, right? So again, we are simply assigning a function value to this variable. And since this variable was defined with const, it is now in the temporal dead zone, and therefore we get this exact same error message as before. And the same, of course, is going to happen with the arrow, right? But now let me show you what happens when we change these to var. So do you think that now it will work somehow? Okay, we still get an error, but it is another error message here. So right now, add expression is not a function. And once again, the same is going to be happening for the arrow. Okay, and now let's think about the reason for this different error message here. So, as you already know, any variables declared with var will be hoisted and set to undefined. And now, this add expression here is essentially that. It's a variable declared with var, and so right now it is undefined. And then here we are trying to call undefined, basically. So we are doing essentially this. So undefined, and then we are trying to call it. And so we should now get the exact same error. So you see, it's not a function. And in fact, let me show it to you here even better. So add arrow should now be undefined. And indeed, here it is. And once more, that is because we now declared these two here with var. Okay, so let's simply take both of these out. And for you to keep this as a reference, I will leave this one as a var and this as a const. But just know that both of them will not work. The only function that you can use before declaring it is the function declaration. Okay, so now we covered all the rules here and saw how hoisting works. But now let's show me a very cool example which can demonstrate a pitfall of hoisting. And so it's a mistake that we can easily make if we're not careful and at the same time use var to declare our variables. So let's just write example here. So to start, let's declare a fictional function here. So a function which is a function declaration, and that's important. So a fictional function that will delete the shopping cart. So let's say that we have like an e-commerce website or application. So let's simply log here all products deleted. And so this is a dangerous function, okay, that we should not be calling without care. Next, let's also declare a variable which contains the number of products. And so now I will use a var, and this will then show you once more why we should not use var. Products equals 10. And now here at the top of our code, we are going to write some logic which will delete the shopping cart whenever the number of products is 0. Now we already know that 0 is a falsy value, and so we can write this, right? So in this case, we want to call delete shopping cart. All right, so again, here we have var num-products set to 10. But then here we have this logic in which we want to write that when there is no product, we want to delete the shopping cart. But now watch what actually happens. So we get all products deleted, even though num-products is actually 10. So why did that happen? Well, it is because of hoisting. So at this point of the code here, the num-products variable is in fact not 10. Instead, what is it? Well, it is undefined. And that's because of the way hoisting works with var variables. So we just show that to you very quickly. And so indeed, now here from line 71, which is this one, we get this undefined. And we know that undefined is also a falsy value. And so therefore, this code will then still execute even though we thought that num_products is 10. But in fact, it's undefined. And so that will also trigger the execution of this if block here. Now, of course, this is just a fictional tiny example, but in a large code base with thousands of lines of code and without best practices, something like this can totally happen. And it's going to be a bug that will be hard to find. So what are these best practices? What is the conclusion of all this? Well, as a first step, as I told you many times, just don't use var to declare variables. Use const most of the time to declare variables, and let if you really need to change the variable later. Also, in order to write clean code, you should declare your variables at the top of each scope. That will just make your code at least look a little bit better. Finally, always declare all your functions first and use them only after the declaration. And this applies to all types of functions, even function declarations which are hoisted. So you could use function declarations before you declare them, but still, just don't do that. It's just not clean, okay? So what I just told you are the best practices, not the rules of how it works in JavaScript, all right? And now just to finish, since we're talking about the differences between let, const, and var here, let's just take 2 minutes to see yet another small difference between them. So let's again declare one variable for each. Let y equals 2. So the values don't matter at all here. And now let's just take a look at the window object in the console. Okay, x has been, of course, z here. And so let's now take a look here at the window object here in the console. And window is the global object of JavaScript in the browser. And you can see all kinds of stuff in here. For example, the alert window that we have used before, or also some other functions that we probably might have used already before. So I'm not going to go into that here. But what is important, so let's go all the way to the down here, and you can of course explore this by yourself in case you're interested in. But what matters here is that beside all these functions, we also get a property of x equals 1. And that's exactly the variable that we declared right here using the var keyword. However, we cannot find y or z here anywhere in this object. And that's because they were declared with let or const. And so variables declared that way do not create properties on the window object. So let me actually demonstrate this to you even better. So we can say, or we can test x equal window dot x. So here we are testing if x is actually a property of the window object. And so if it is, then of course x must be the same as window.x. And actually it is true. And now the same for y and z. And so in these cases, it is both false. So in conclusion, I just wanted to let you know that variables declared with var will create a property on the global window object. And that can have some implications in some cases. And again, you can take some time to explore the window object because it's quite interesting to see everything that is in there. All right, but with that being said, let's now finally move on to our next topic, which is going to be the this keyword.